Okay, fine. So we can begin with arrays topic today. And those who are new, please go through the topics of time complexity so that you can get some basic understanding. And as we go ahead with every problem, we are going to calculate what's the time complexity of our problems, right? Okay, so can anyone give me the definition? What do you mean by an array? What do you mean by an array? I think most common data structure to everyone.
It's just collection of elements, that's it.
Okay, in computer science terms, if I'm just taking in general computer science term, what does an array mean?
So it is a data structure that is in a form of list to store variables or values, you can say.
Okay, so the proper definition of array in terms of computer science, what we all have known is that it's a continuous collection of elements, right? 1, 2, 3, 4, 5. What kind of elements does it store? So all the elements that you store inside an array has to be of same type. Am I correct? Am I correct? It's not that I can say that at one of the positions I'm able to store an integer, at the second position I'm going to store a float. That should not be the case. Array does not support such things. What it does is that it can store only elements of same type. In what manner it can store? In a continuous manner. Correct? The entire memory segment would be allotted. Suppose that I wish to say that inside my array there would be 5 elements, then corresponding to the 5 elements, right? And let all of these elements are integers. Each and every integer requires 4 bytes, correct? Then what happens is that a continuous segment of 20 bytes gets allocated, because I know that 5 elements into 4, these amount of bytes would be required to store 5 integers for us, correct? Okay, then what would be happen? Suppose that from the 0th byte onwards, my storage is starting off for the array elements. From 0 to the 3rd byte, element 1 would be stored. From 4th to the 7th byte, 2 would be stored. 8 to the 11th byte, 3. Then post that 12 to 15, it's gonna be 4. And at the end, 16 to 19, that's gonna be 5. This is how my elements are gonna be organized here in a continuous manner, correct? It's not that from 0 to 3, one is getting stored and the second element is getting stored from 7 to 11. This is in between these segments of memory. The second element that I wish to store is coming off after one. The memory gap should not be there. That's how arrays are getting stored. They should be of same type of elements, correct? And what else? They should be stored continuously. Now my point is, corresponding to arrays, we don't require to remember in between what series of bytes my elements are getting stored. How do we actually locate the elements corresponding to an array? Can anyone tell me? Utilizing?
Index.
Yeah, utilizing indices, right? I just say that 0, 1, 2, 3, 4. From 0 to n minus 1, these are the series of indices. And if I just say the name of my array is being declared with the variable ARR, then I can just say that bring on the element that is stored at the second index. It's going to straight away query that the second index is being started off from what particular memory segment. So we can say that if 0 is my base address of my overall array, the second index is getting started off from the 7th byte, right? So in between 7 to the 11th byte, what particular element is getting stored? 3. So that would be fetched accordingly. So whatever, based on the indexing, right? The fetching of elements is a big O of one operation. The amortized time complexity to fetch an element from the overall array, whatever we are having, is a big O of one operation. So the access of elements is quite fast. Correct?
One small doubt. So what does amortize mean?
Amortized means the worst case time complexity.
Okay, amortize means first. Okay.
Fine. So my point is right now, suppose I say delete the second index element. Correct? You are having n elements. Suppose that I'm saying you are having n elements inside an array, and from the array, right, I ask you delete the 0th index element. Then how you are gonna how the rest of the elements would be organized? Or you can just say that not the 0th index element, let any ith index element. Let me remove that. Let me try deleting that from the overall array. Then how the organization of the array should be looking like? So basically I'm saying that 1, 2, 3, 4, 5, let this be 5, 6, 7. Many things are going to be there. Many integers more can be there here. So the second index element 3 I'm going to delete. Then I feel 0th index, first index remain same, right? The second index would no longer be 3 since it has been deleted. Then post that the second index would be shifted to element 4. Accordingly, third index, fourth index, and fifth index would be shifted. Correct? They would be shifted by one element towards the right, the index values, or on the counterpart, or I can say the elements that were previously at the third, fourth, fifth, and sixth index, they have shifted towards the left by one index. Then tell me for one thing, what kind of operation it is, means how costly this operation is gonna be based on the array, whatever we are seeing.
Would be the length of the array.
Okay, approximately it should be length of the array, right? Why?
Because in the worst case, if you remove the first element, that means each element will go back, right?
Yeah, so if I am removing the first element, right, in the worst case, what's going to happen? Every element, whatever we are having, 2, 3, 4, 5, 6, 7, every element would be shifting towards the left by one position, right? Because in case of deletion of the first element, that is at the 0th index, your first index element would be becoming the 0th index, then the first index, then second index, third index, fourth index, and fifth index, correct? Every element would be shifting left by one position. So I am doing basically an operation of the order big O of n. Every of the rest n elements, whatever I am left with, that is getting shifted towards the left position. That is getting shifted by left position by an amount of 1. That's what I can say, correct? Okay then. Similarly, if you are adding an element at any random position, what should be the scenario? Can anyone tell? If you are trying to add an element between any two at any random position, again, let's suppose that you are having 1, 2, 3, 4, 5, 6, 7 inside your array, and then I say you that add an element 9 here in between 4 and 5, add an element 9 here. Then what should be the time complexity of this? Then 1, 2, 3, 4, whatever were their previous indices, that remains as it is, correct? 9 comes and each and every of the element, right? 9 becomes the index 4 element. Each and every of the element gets shifted towards the right by one position. Am I correct? Rest all the elements that are towards the right of 9, they will be getting shifted by one position. So their index value would be increased by 1. Fifth value, this element 5 would be getting its new index as 5, 6 would be going to 6, 7 would be going to 7, and 8 would be going to 8. Correct? That's again in the worst case. Every element in the worst case, what can happen is that I can try adding an element towards the in the beginning. So I can just say that add 9 here, then each and every element. Then this beginning element would be becoming the second element for me. So it is getting shifted by an index towards the right. Similarly, this will be becoming index 2 for us, got shifted towards the right. So every element would be getting shifted towards the right one by one, right? So again, the insertion is also a big O of n operation, quite costly. Both insertion and deletion inside array are quite costly. Any other thing that anyone can tell me for arrays, in terms of arrays? In terms of arrays, any other thing that you can tell me? Anyone?
Searching. Okay, searching the element might be not indexing, but searching would be again O of n, right?
Something else. Searching is definitely something different. Right now, with the in terms of storage, we are getting.
Okay.
So I think if we change the nature of array, the searching can be quite efficient. That can happen, right?
Okay.
Something else that anyone can tell me related to arrays. Once the size of the array has been declared, once you declare the size of an array, it cannot be changed. Correct? Once the size has been declared, it cannot be changed. The size of the array is always fixed. Let me say that you declared that while the compile time, you declared that while the runtime. That does not matter. Once the size of an array has been declared, it's always fixed. You cannot change it. So that's how the nature of array works. I hope basics of arrays are clear to most of you. How does array works? What kind of elements does it store? Access is big O of 1. Insertion, deletion, all are big O of n. time complexity. Worst time amortized complexity corresponding to them is going to be big O of n. Correct? Same nature of elements they store, and elements are stored, right, in a continuous manner. A chunk of memory gets allocated. Certain bytes to certain bytes is being occupied by a certain element. Are all these points clear to everyone?
Yes, from test.
Tell me one thing. Arrays being seen like this. Now my point is, we do have arrays in Python as well, right? But again, we are having a specialized form of what we call as lists. Correct? We have list as well. Then just I can say that we just say that let the name of the list be L, and I can just say equal to that of a set of empty brackets, empty square brackets. Python dynamically can detect that fine. The object corresponding to the variable L is gonna be a list.
Raman, am I audible?
Yeah.
I think someone was asking some question.
I don't feel it.
Someone was asking some question how array works. That's it. I mean, is it not audible to you? That's it.
Did anyone else heard that? Hello.
Yes, okay. Then.
Fine. So my question is, right? Once I declare inside Python something called as list, going forward, we are going to work with majority of the time with the concept of arrays with the help of list only. Why? Because it's going to give me a lot of functionalities. Correct? It's going to give me a lot of functionalities, like I can directly sort the array whenever I require, right? I can take out the max min. Majority of the things I can go for negative indexing for accessing the elements in a backward manner. So I'm going to utilize lists. But the fact is that how list work is that list supports not only same kind of elements, but inside that, once you have stored integers, you can go for float elements as well. You can store strings as well together. It's not that I am keeping a list of strings only, or I am keeping a list of integers only. That is supported. Along with that, a variety of elements together inside the same list, that is also supported. So my question is, can we say that list in Python is an array? Can I say that?
Yes, I think so. The basic implementation is similar to array, right?
But the nature is not matching up. Am I correct?
Yes, I mean, the list also has, the indexing. That means it is a continuous block of memory only.
Even the memory thing is not same.
Is it not same? I mean, it should be the same, right? If you're going to index 0, 1, 2, that means
So
that memory is
you
same.
are missing one point. The first thing, arrays have all elements of same nature, whereas list can store every element that may or may not be of same type. So that
Okay.
definition is getting void.
Okay.
So we cannot call list as a proper array.
Okay.
What we can call them? So I think in JavaScript and many other languages, such kind of things are getting supported. Python, we are already having an example. Many other languages can support data of these kind. Correct? What we call them? Can anyone tell? We call them containers. What we call them? We call them containers. Correct? What are containers? Basically, can anyone tell me what are containers? Containers are a specialized form of storage, right? What actually supports operations of existing data structures like array? Existing data structures, whatever you are having, right? Those functionalities are gonna be there, as well as some added functionalities are gonna be there as well. Inside a basic array, whatever we have seen, right? There is no functionality such as you can calculate the size of the array. You cannot do it directly. You have to start up from the first element, you have to go till the last element, then only you can conclude how many elements are there. Or you can say that if overall the size of the array, how much memory the overall array is occupying, if I know that, let the memory be m, and what kind of element is the overall array storing, let it be integer. I divide it the overall size by the size of a single integer, how many elements are going to be there. I'm going to calculate that. Correct? That can be a way. Or else I have to traverse to entire elements, whatever I'm having. One by one, I need to count. That can be a thing, right? But I am having an additional feature in terms of my list, right? I can straight away pass it to a length function, and it's going to return me that fine, how many elements are there inside the list. Moreover, list has a great support that it is giving me kind of a flexibility. Not only I can store array of the elements of same type, or it can store elements of different types as well. Correct? Additional functionality it is. Fine. Elements are definitely gonna be, we are able to visualize that elements are stored next to each other, but internally that's not the case. Correct? So fine. One thing is that list is supporting indexing. At index 0, something is being kept. Index 1, something is being kept. Index 2, something is being kept. Indexing is definitely there inside list. So there is some form of continuity. But my point is, how does, if suppose a continuous nature of elements are getting stored inside our list, then why do the elements are differing in type? How they can actually differ in types? Can anyone tell me? Does anyone
Because
have the answer for that?
because they are not storing the values within this list.
Exactly. What else they are storing?
So they are storing the address or the reference of this particular data type, which is like within this index, if it is a string, it is storing the reference of that value from that particular memory address.
Yeah, that's the correct answer. So see, for one thing, all of you agree with me, every data you are storing inside Python, let that be 1, 2, a string, let's say, all of them are getting stored as an object. All of you agree with me on that? Everything, every data that you store inside Python, let that be numbers, let that be strings, let that be list, let that be any kind of data, all of them are objects. Correct? All of them are objects. See, for one thing, let me give you a quick demonstration. Let me just say that I am storing inside the variable v the number 2. Correct? Then see, for one thing, how can I try visualizing this? I can say that an object corresponding to 2 would be created. Where this would be created? Corresponding to the value 2, an object would be created. Where this will be created? Inside the heap memory. Correct? And this v remains inside your stack region, and it keeps a reference to the address wherever 2 is holding the place inside heap. Fine. Correct? So basically everything inside Python is an object, and whatever variables you declare, they serve as a reference to wherever those objects are occupying space inside heap. Got the point? You just try id of v, that's gonna give you the address inside heap, what memory location is being occupied by the reference, whichever is actually pointing to the object. Fine. So normally in C, C++, we have already seen that memory occupied by our integers are not more than 4 bytes. Fine. But here, once you try calculating, right, I can go ahead and say that, try calculating the size of the variable v. So you can just say that v dot size of. Fine. Let me try calculating this. So they are giving me that it's holding an overall of 28 bytes. Why is it gonna be so? Because here v is not only containing a number, it's containing the data as the value as 2 only, along with a hell lot of attributes. What kind of attributes this integer variable v is storing up? You can try the dir method and it's gonna bring you everything, right? These are the following attributes and methods what your v is actually holding additional to that of its value. A lot of things are gonna be there. Correct? So every data that we are storing inside Python is an object. Correct? So how does list manages a lot of things, right? A lot kind of data. So fact is that list says us that, okay, do one thing. Still, the data are gonna be adjacent to each other. But here, what I'm gonna do is that inside the list, you can hold different objects. Everything is an object. Let that be a string, let that be number, let that be a float. Everything is an object. So do for one thing, suppose that you wish to store 2 inside the 0th index. You declare, let me address that this region where I'm actually creating the object, let this be heap. So inside this heap, I'm going to create an object of 2, 3, 2.2, let's say, and as well as a string. These are all objects, and at what memory locations they are holding the place in heap, those memory locations are being stored uh, as the data of my list. I am actually storing inside the list at what particular memory location 2, 3, 2.2 and string, these data are getting stored. So let this be at memory location x1, memory location x2, memory location x3 and x4. These are the memory location. These are actually being held by my list. Now, whenever I say whatever is my list, bring its content of the 0th index, it's going to straight away search. It's going to straight away search that, okay, what is the content here? It is corresponding to the content of memory location x1. What is being kept at the memory location x1? 2 is kept. So that is getting returned ultimately. Got the point? That is getting returned ultimately. So that's how my list can manage so many kind of data. Fine. It's actually storing the addresses of different objects of my heap region. Correct. Now, if I say that, let me update the data of the 0th index inside list. I'm going to update that to 4, let's say. I'm going to update that to 4. It's no more going to be 2 for me. It's going to be 4. Then what should happen? Anyone knows that?
It would create a new object and point to this 4, right?
Yeah, it's gonna be creating a new object 4 and x1. This and suppose that this is x5, a new memory location. So overall, this value would be updated to x5. The value of the 0th index is gonna be updated to x5 for us. Okay, 2 still exist into the memory, but right now my 0th index of the list is being referring to the location x5, which is holding the data 4. Whenever you say that x, suppose that I'm taking an example here, whenever you are saying that, let me have 2 variables x equal to 5, and let me say that I'm having another variable here y equal to 3, let's say. Then corresponding to that, what happens every time you execute this block of code, corresponding to the reference x, a new object 5 would be created, y, a new object 3 would be created. Correct. Every time I wish to store something, an object would be created in the heap and its reference would be assigned into the stack, and that reference is going to hold the memory address wherever the object has been created. Okay. Now, if I say for one thing, suppose x equal to 5 and y equal to 5 as well, then what's going to happen? X equal to 5, y equal to 5. Suppose that both of the references or variables, whatever we are creating, that is going to point to the same number 5. What can happen here? 2 different objects of 5 would be created, or same 5 would be pointed by both x and y. So what's basically would be happening is only a single 5 would be created. Single 5 would be created. You try printing the addresses of both x and y here. What is it? Okay, I'm sorry, I didn't do this. Did we get it? Okay, I'm sorry. Let's go ahead with that. Let me delete this. So I think both the memory locations are same, right? Corresponding to x and y. Is it that? The memory locations of both x and y are same. Typically, what is happening? Whenever 2 variables x and y point to the same data, right? Definitely data is created once only inside the heap. X is also pointing to 5, y is also pointing to 5. Correct? Now, if you say that x equal to x plus 1, then what's going to happen? Separate object 6 would be created, x would be assigned to the data point wherever 6 has been created, to the location basically inside the heap wherever 6 has been created. That's it. And y would be holding the address of 5. That's how overall your memory is managed simply in some simple terms. That's how overall memory is getting managed inside Python, right? Okay, what if I say that, what if I say that uh, x equals to x plus 1, and let us suppose y equals to y plus 2. Then initially both x and y were pointing to the same element 5. Then corresponding to the operation of this, x would be now pointing to 6, y would be pointing to a new object 7. What would be happening to 5? 5 is not being pointed by any element, let's say. Then what would be happening?
Uh, should be deleted, right?
Okay, so see, for one thing, inside Python, we have a concept, something called as garbage collectors. Am I correct? Garbage collectors. What happens is that whenever any entity, any object, let's say, is not being pointed by any reference, object is not being pointed by any reference x and y. Suppose that it might have x, it might have n number of references earlier, but right now it's not getting pointed by any of the references. Then garbage collector identifies such object that it is not getting used anyhow right now. It's gonna be whatever memory it's being occupied, it's gonna be freed accordingly. Just like Java, right? Inside an object, you have a counter. How many references are pointing to this object? Right now, for this example, 5 is an object, and here it is being pointed by two references, x and y. Correct? Now, if I just execute these two lines of code, 5 will not be pointed by any reference. So, garbage collector can point to these objects, can collect these objects and free the memory accordingly. But observe one thing, yeah, for large data structures such as list, maps, sets, whatever we are having, this thing is very handy. But whenever you are having small range of numbers, small numbers, typically from -5 to something around 200, right? These small numbers are actually interned in Java. Sorry, not Java, Python. These are interned in nature. That means Python never deletes them. It may be the scenario that sometimes later on of your program execution, the requirements of these numbers may arrive again. Then what can happen is that the interning features work well. Again, new references would be created and they are going to be straight away assigned to these numbers. So they are going to be always stored. Okay, small range of numbers from -5 to typically 200. Roughly this is the range. These are interned in Python, right? They are never deleted. Even if no reference is pointing to them, right? Still utilizing, if you are having the memory location, if you try accessing them, you can actually get the data points from here. Fine, this is a concept inside Python that small numbers are interned. Correct? Are all these points clear so far? Are all these points clear so far?
Yes.
All of you, a little bit of discussion in list and arrays, whatever we have done. You got the difference? You got the difference how list is a little bit different as compared to that of our original array. Tell me that. So list comes up with lots and lots of functionality. To solve most of the array-based problems, we are going to utilize that from now onwards. Is everything clear? Can we move on then? All of you tell me that.
Yes.
Yes.
Okay, let's take one of the most simplest problem of our arrays. I think majority of you might be aware of this problem. You are given all numbers between 1 to n except 1, right? Your task is to find that missing number. Given an integer n, right? From 1 to n, every number would be given to you, just like this. N equal to 5 and all the numbers from 1 to 5 are present except 1. What is that missing number? I have to find it out. How many of you know the question already? I think majority should be knowing this or should be aware of this problem. Okay, fine. Think about the most naive approach that I can utilize to solve this question. And after 2-3 minutes, give me the answer, whatever comes to your mind. Most naive approach, or typically the brute force approach, utilizing which we can solve this problem. Try this, all of you. Hello, anyone?
Yes, Raman, might be we can check presence of each number until the range of an example. It's since the numbers are in order, right? So might be we'll check whether 1 is present or 2 is present or 3 is present in the given list.
Okay, so given to me is that all the numbers from 1 to n,
Condition.
yeah, all the numbers from 1 to n should be present inside the given list. Am I correct? Whatever is the given list of numbers, 1 to n should be present inside that except 1.
Hmm.
Correct? So I'm going to run a loop, run from 1 to n. Whatever number x from here is not present into the list, stop the iteration, print x. Can I say that? Can I say that? I can just
Yeah,
do
but the
something.
condition should be like everything should be in order.
Nothing,
What if the array is not in order?
nothing is
Like,
such like it.
exact-
From 1 to n, I'm
no,
going to
no,
run a loop. Okay, yeah, go ahead.
okay.
You are just
In the
running a
example,
loop.
like the array is not in order, so when it is not in order, we can't take this method.
Okay, let's see that. Let's see that. Fine. So I'm saying that here the given number is 5. I'm going to run a loop. Check from 1, 2, 3, 4, 5. Check all the numbers one by one. This is my given list 2, 3, 1, 5. 1. After iterating 3 numbers, I found that 1 is present. All good. Fine. Check for 2. After iterating the first number only, I check 2 is present. All good. Go to the third number. After iterating two numbers into the list, I got the 3 is also present. After iterating all the numbers of the list, I cannot find 4. So I'm going to stop here. I'm going to stop here. I'm going to say 4 is the missing number. Correct? Correct?
Yeah.
So even
Yeah.
if the array is not in order, that does not matter. Fine. This is a kind of a start to the end search. Let that be any number. If the number is found at any of the ith position, I can conclude element is present, else element is not present at all. And stop the iteration there. As per the question, only 1 is missing. Correct? Only 1 is missing. So that's
Okay.
gonna be my answer. I'm gonna print that. No need to search further. What's the time complexity of this approach? So in the worst case, from 1 to n, right? From 1 to n minus 1, I can assume from 1 to n minus 1, everything would be present and the nth number would be missing. So so I can say that from 1 to n minus 1 corresponding to every number, roughly there would be n minus 1 searches into the array. Array is gonna have exactly n minus 1 numbers. That's what is given. How many numbers inside the array? N minus 1 exactly. So corresponding to all the first n minus 1 numbers, roughly there's going to be n minus 1 searches in the worst case. Corresponding to the nth number again, there's going to be n minus 1 searches into the array. And I am not able to find the nth number. So I'm going to print n is my final answer. So corresponding to all the n numbers from 1 to n, you are performing n minus 1 searches into the array roughly. What's the number of operations I did? N into n minus 1. Can I say that? Can I say that? All of you agree with me here?
Sir.
Okay, got it.
All of you agree with me here? We are in total performing n into n minus 1 searches corresponding to all n numbers. In the worst case, we are performing n minus 1 numbers to be searched into the given list of numbers. So what's the overall complexity? Can anyone try telling me that?
N square.
Okay.
What is it? Go ahead and say
O(n) square.
we go of n
Of-
square minus n, and the power of n is smaller as compared to n square. I can neglect. Overall, it's gonna be big O of n square. Given the constraints they have, maximum length of the array is 2 into 10 to the power 5. Will our this complexity hold the solution? Should it be passing?
No, sir.
So basically n square is leading me to how many operations at max? If your array is this point large, this number large, right? Length of the array is this number large. How many operations in total we are doing? So at max, you can perform n square operations. That's the upper bound, right? That's what my big O suggests. So it's going to be 4 into 10 to the power 10. It's fairly greater than 10 to the power 8. So this approach is not going to work for us. So we cannot take this approach based on the worst case scenario. What should I do? What else I can think of to solve this problem?
Maybe we can take the sum of first natural numbers,
Yeah.
subtract it.
Okay, so what can I do is that what we are effectively seeing is 1 plus 2. Let's write the first 5 natural numbers, right? 1 plus 2 plus 3 plus 4 plus 5. Let's suppose I'm having a sum of first 5 numbers, first 5 natural numbers. That's the expected presence, right? 1 to n, they should be present, but 1 is getting absent. Correct? What is given inside the list? 2 plus 3 plus 1, right? Plus 5. These are the content of my list. I have taken an addition of all of them. Now I say that from the first and natural number, subtract the sum of all the numbers given inside the array. Then I think this 2 will be cancelled out. 3 would be cancelled out. 1 would be cancelled out. 5 would be cancelled out. And we would be left with the missing number 4. Am I correct? Only 1 is to be missing from here, right? So what I can straight away do is that no need to recheck again and again. You do for one thing. Whatever is the given set of numbers to you, take out a sum of it, and that sum needs to be subtracted from the sum of first n natural numbers, whatever has been specified. Correct? Whatever has been specified. If I subtract both the sums, the missing number is gonna survive. So I'm gonna print it accordingly. That's it. Nothing more, right? So again, to calculate the sum of them of my given list, what should be the time complexity? I think the sum of first n natural numbers to me is n into n plus 1 divided by 2. Straight away I can calculate that based on the arithmetic progression formula. Correct? And if I just say right now that I need to calculate the sum of sum of n minus 1 numbers given into the list. So I have to iterate through all of the numbers, I feel. Whatever
Yes,
is the
sir.
content of the list, I have to iterate through all of them. N operations for that. N operations for
Yes, sir.
that. So this is a single formulation, would require a single operation for me, and this would be requiring an operation. So overall, I am doing big O of n operation in order to solve the problem, right? Because just one thing, one single loop would be required to calculate the sum of the given list. Only a single mathematical calculation is required for the first and natural numbers. Another thing is left, whatever is the sum you calculated and whatever is this formula n into n plus 1 divided by 2, you subtract the sum of the array from this overall given value and you get the missing number accordingly. You just directly print that. So again, that subtraction and printing would lead to again constant operation for us. So overall, it's gonna be a big O of n time complexity solution. So if I right now say, if that's a big O of n time complexity solution to us, right? Is it getting fit into our given constraints? Is it happening? So at max, I am performing no more than n operation to solve my problem. So number max operation can be n here as compared to the n square approach we have taken previous as into the previous solution. So 2 into 10 to the power 5. Correct? That's the maximum operation performing. This is fairly lesser than 10 to the power 8, the maximum allowed limit. Fine. So yeah, this solution is gonna definitely fit into the given constraint. So I'm gonna proceed ahead with that.
Rahman, one small doubt.
Yeah.
The 10 power 8 weight is mentioned in the question.
Inside the question, it's not gonna maintain, it's not gonna be mentioned, but majority of your platforms do support that 1 second is the time limit and you are gonna perform 10 to the power 8 operation, not more than that. So
Okay.
the safe limit is 5 into 10 to the power 7, you can say. But yeah, at max, you can go till 10 to the power 8 for any one. And the time limit is going to be always 1 second. Python is interpreted language, whatever we are taking here. So you can assume that at max 5 into 10 to the power 8 operation, this is what we can perform. Because the interpretation is going to take some overhead for us. So at max 5 seconds may be given to you. As compared to 1 second of C and C++. They are pretty faster, right? For solving these problems.
Good.
Okay. Fine. Is the solution clear to majority? Is the solution clear to everyone?
Yes.
Should I code this for you people or you people can do it? This is a pretty straightforward question, I feel. What you have to do is that you have to just take the value of the n, you have to take the value of input, whatever we are having, n minus 1 integers, and you have to just say whatever is the missing number, that's what is required. So let me open an IDE and let's try there. Where is Python? Python 3 we can have. So straight away I would be requiring what? Two things, right? Firstly, n would be an integer. So you can just say take an input. So if I am utilizing the input function, then by default, what kind of input comes to us? Can anyone tell?
It's a string.
Yeah, it's a string. So I have to typecast it, right? To an integer. Okay, now the fact is that you have to take the array as well. How you're going to do that? So I have to say whatever is the array that they are providing, that is a. So if I just consider this entire thing to be coming as an input, right? Entire line to be coming as an input. So I have to utilize the input function again. I can just say that input is getting utilized again. But the fact is this input is going to consider the entire line, whatever we are having, let's suppose 2, 1, 3, 5 as a list. This is how the input is going to look like in terms of an array. Fine. So I have to convert that. How to do it? So I can just say that first split it, right? Right now it's an entire line of numbers and that is contained inside a string. So if I try splitting that, input dot split, fine. Then what will be happening? I think the split operation is going to convert that to individual strings. Am I correct? The space is going to be eaten up and it's going to get converted to individual string. Then I have to convert that to numbers, I feel. So I can just say that map it to integers, whatever we are having right now, and then convert that to a list. Am I correct? Have I done, or have I utilized the same correct syntax? Then tell me. First, whatever the line would be coming, split that into individual strings, converted each and every of the string to integers, and then converted that to a list, right? Fine, this part is done for us. What else do I require? What is the overall sum, right? What is the sum of first n natural numbers? So I can just consider that as n sum, and that's gonna be n into n plus 1 divided by 2. Integer division it should be, right? So you are not going to have the float division, it's an integer division. So double slash marks, double division marks. And what is the array sum? It's gonna be. What is the array sum? It's gonna be. So I can straight away say that I can iterate to every element of the array and keep on subtracting that from the n sum. That's what I can do. So for element I am having, or just for num, whatever I'm having inside the array, right? You just do for one thing, whatever inside the n sum value overall, whatever you are having, you keep on subtracting the number from that you are right now having or pointing to with the variable num inside the array. That's what I can do. Whatever is the content that remained inside the n sum, that's going to be my final answer. So straight away I can try printing n sum at the end. That's it. I don't think anything should be left. So yeah, let me try running it. Let's see whether we have done things correctly or not. So the answer is coming out to be 4. Any other example you may try? Suppose that 6 you are taking here, 2, 3, 1, 5, 4. Then I think 6 should be missing off from here. And yeah, 6 is our answer. So everything is correct. I can try downloading it, try submitting here. I've already, okay, so I haven't logged in. Let me log in. Done that utilizing some other languages. Let us try with Python. So where is it? Code, yeah, open, submit. Yeah, it's accepted. So I think this is a pretty straightforward problem and most of you have already done this. Am I correct? Related to the arrays, and all of you must have done this problem. Am I correct onto that part? Am I correct?
I didn't do it.
Okay, but I think someone has given the answer already, right? Sanskar, I feel, right?
Yes,
Already done that, right?
yes,
Previously. This is the most common problem anyone can have. Okay, then. Okay, fine. Let's move on to this problem. Let's discuss the approach. We can have the coding part in the next day as well. So they have given you an array, right? All the array elements. Let me mention the question. You are given an elements from 1 to n. Again, from 1 to n, all the elements are being given. They can be of any order. They can be something like this. So the question is, you have to swap any two elements. Okay. what is the minimum number of swaps I can perform to sort the array? That's what the question is given all about. Fine. Your array can be given anything like this, right? You have to perform some sort of swaps between any two elements. You can select, you can swap them. What is how many swaps you have to perform at min, right? Minimum what swaps are required to sort the entire array. Again, the first question is how many of you have solved it? How many of you have already solved it? Minimum swaps to sort an array. Now the question here is, there is a hack here. All the elements that are given to you are in between 1 to n, where n is the size of the array. Fine. We have to perform minimum number of swaps to sort the array. Somehow we have to do it. How many of you have solved? Already. Please observe, I'm just giving the intuition today. Next day we can try coding this part, right? So the thing that has been given to you, let's suppose you are having 2, 3, 5, 1, 4. This is the nature of your given array, right? All the elements, if n is the size of the array, right? All the elements from 1 to n would be present inside the array, and every element would be present at most once. Now, what is the minimum number of swaps I would require to sort the array? Sorting means it's gonna be 1, 2, 3, 4, 5 in ascending order. What is the observation that you are getting after I sort the array? Tell me that. After I sort the array, what is the observation that I'm getting here?
Sir, maybe like every number should be on the index, maybe,
So
or at
every
index plus.
element x is present at index x minus 1. Am I correct? Every element x is present at element x minus 1. This is the observation that I am having. What if I sort the array? Correct? All of you agree with me here, right?
Yes.
All of you agree with me. Okay, so let's see 2, 3, 5, 1, 4. Let's start off sorting. Let's start off sorting everything from the 0th index onwards. Tell me for one thing. At the 0th index, element 2 is residing. So at the index 0, 2 should be the content. Should it be that? 2 should be the content at index 0? I don't think so, right? Here the content should be 1. So let's do one thing. Since the content is different, let me try shifting 2 to its sorted position. What is the sorted position of 2? Let me try shifting 2 to its sorted position. I think if you want to sort the array, 2 should be going to index 1, right? 2 should be going to index 2 minus 1. So I'm going to swap index 1 element with my current index 0 element. Got the point? Index 0, what is the content? 2, not equal to that of 1. What ideally should have been, correct? Then I'm going to say let's shift 2 to its sorted position. What is its sorted position? 2 minus 1. That is first index. Swap the index 1 element with the current index 0 element. Okay, so if I swap, how the array is going to look like? How the array is going to look like? Tell me. How the array is going to look like? It's going to be
3,
3, 2, 5, 1, 4. Okay, then next at the index 0, it's still not sorted. Index 0 is still not sorted for us. Then what should I do? Index 0 is still not sorted for us. Then what should I do?
Again, swap it with the right
So
position.
right now, index 0 is having element 3 for us, correct? Index 0 is having element 3 for us. So 3 should be shifted at what position? Tell me.
Second index.
So 3 should be going to index 0 right now is having 3. It should be going to second index in order for the entire array to be sorted. Swap 3 with the second index element. So 5 comes in. So 5 comes in, right? So I think the array is going to change right now to 5, 2, 3, 1, 4. Content of index 0 still not equal to that of 1. Again, what we are having is a different element 5. Then what will be happening? 5 needs to be shifted to index 4, I guess. Swap. 5 needs to be shifted to index 4. 0 is having 5. It should be going to index 4 in order for the entire array to be sorted. That's what with certainty we can say, right? Swap. So what we are getting here, 42315. Correct? At index 0 still this is 4 only. At index 0 still it is 4. So it should be going to index 3, I guess. Okay, 4 and 1. Swap. And finally we are seeing that after this swap, my entire array is getting sorted. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Array got sorted. How many swaps we did? 4 swaps, right? See what the main intuition behind this is. The question has a great exploitation that every number is in between 1 to n. That's why we are able to do it. Else it wouldn't have been possible. Had they given you there one element is 16 and number of element inside the array is 5. Why would you shift 16 to the index 15, right? Index 15, any element 16 cannot be shifted to index 15 because the overall size of the array is 5. Then in order to sort such an array, you have to come down to certain standard sorting algorithms. But here, without any standard sorting algorithms, we can try some sequence of swappings in order for the entire array to be sorted. No, nothing special we have to do here. Just some observation and we did the entire thing, correct? Okay. See for one thing, how the entire sorting took place. 2 got sorted with 3, then 3 got sorted, 2 got swapped with 3, 3 got swapped with 5, I feel, 5 got swapped with 4, and 4 got swapped with 1. Correct? 4 got swapped with 1. So I think these are, So I think this is making an entire cycle for us. Is it happening? This is making an entire cycle of swaps that we have to perform. Okay. And this cycle is containing how many elements? How many cyclic shifts we have to do? 2 got, so here 1 shift, then 1 shift, then 1 shift, then 1 shift. Overall 4 shifts we have. That's why how many in total shiftings we have done in terms of a cycle? It's 4 shifts. 4 shifts are equivalent to that of 4 swaps, whatever we have performed here. Correct? 4 swaps that we have performed here, nothing else. Okay, after these amount of cyclic shifts, whatever we have done, right, our entire array is going to be sorted. So then based on this intuition that entire elements that we are able to swap, in order for the entire array to be sorted, they are forming a cycle. They are forming a cycle, right? What is happening basically? Firstly, 2 is going to the place of 3. Then 3 is going to the place of 5. 5 is coming to the place of 4. 4 is coming in place of 1. And 1 is coming back to the place of 2. So entirely they are connected in terms of a cycle. Fine. They are connected in terms of a cycle. So how many in total cyclic shifts we are doing? The number of elements. These are 5, right? They would be connected at max by n minus 1 shifts, not more than that. So in total, from 0 till n minus 1, right? These amount of swaps at max I need to do in order for the entire array to be sorted at the end. Correct? The intuition part is clear to everyone. First tell me that. Again, you can have another example like this as well. Let's take it. 1, 3, or let's suppose that it is 2, 1, 3, and then I feel let that be 5, 4, correct? Or try this again at the 0th index. It is 2 for us. Okay, fine. Let this not be 2, 1, 3. Let this be 2, 3, 1, correct? And let this be 5, 4. Then at the 0th index, 2 is there to be shifted to 3, right? At the first index, array is gonna be 3, 2, 1, 5, 4. Okay. 3 to be shifted to 1. 3 to be shifted to 1, correct? Then 1 and 3 would be getting swapped. It's gonna be 1, 2, 3, 5, 4, correct? Then I think here see 0 to 1 and 2. These are in the sorted order for us. The next only thing that is left is 5 and 4. At index 3 and 4, they are residing. 0, 1 and 2 all are into their respective sorted places. 3 and 4 here, the elements are not in order. I think index 3 element 5, that should be shifted to index 4 element. Whatever is the content of index 4, swap both of them. At the end, I am saying that 1, 2, 3, 4, 5. These are the contents at the end after this swap has taken place in the sorted order, whatever I can get. So I think one swap we did here, one swap we did here, and one swap at the end here in total of 3 swaps. How you are able to visualize this? Can anyone tell? See here. Whatever first 3 elements, whatever we are having, right, they are interchanged into the first 3 positions only. So they form a cycle. They form a cycle. I think I say that one, initially whatever we are having two, we started off with two got shifted to three got shifted to place of one, I feel, then one got shifted to place of two. This is how our entire cycle got uh, introduced in terms of the first three elements, because these first three elements are holding positions in some random order of the first three elements, correct? Okay, then I said that at the end we are having 5 and 4. 5 took the place of 4, 4 took the place of 5. So there are two cycles. How many cyclic shifts, how many elements we are having here that are connected? 3. 2 would be shifted to third position, third would be shifted to first position, first would be automatically going to the second position. So in total of 3 elements I am having into this cycle. So 2 swaps would be required for this. 2 elements I am having for the second cycle, 1 swap would be required to this. So overall 3 swaps would be required in order for the entire array to be sorted. Okay, so in how we are actually performing, till the time the ith element is having, the ith index is having element I plus 1, I am gonna shift. If this is not the case, I'm gonna shift whatever arrays I is having, whatever array of I you are having, shift it to its sorted index. That's what I have to do. Shift it to its sorted index. What is the sorted index corresponding to array of I? It's gonna be equal to that of whatever is its value, array of I minus 1. Okay, keep on doing till the time the ith index is getting its required value I plus 1. That's it. At max there can be n minus 1 swaps. That means whatever array, in the previous situation we have seen, whatever array we are having, every element is interconnected to each other, right? Here what we have seen, 2 got shifted to third, third got shifted to 5, 5 got shifted to 4, I feel. 4 got shifted in terms of 1, 1 got shifted in terms of 2. So every element came into the same cycle. So if there are n elements, 5 elements are there into the first cycle, right? So at max, I can perform 4 swaps. I can perform 4 cyclic shifts in order for every element to be going to their respective sorted place. Fine. So that is the maximum number of swaps that we can have. And at min, I think in total, we can have 0 swaps at the minimum. Why? 1, 2, 3, 4, 5. Every element is already in its sorted position. That's the best case. None of the elements needs to be misplaced. None of the element would be actually getting shifted to any other position. So there would be 0 swaps. So answer would always revolve in between 0 to 4. Not more than that. 0 to n minus 1. Correct? Is the intuition clear? That whatever sorting is happening is in terms of a cycle. Every element is connected to each other in terms of a cycle, right? And we have to shift towards the right, or we have to go clockwise with the shifting part. And if there are n elements into a cycle, we are actually performing n minus 1 swaps in order to sort the cycle, or in order to sort the entire array. Is this intuition clear? That can be at min 0 swaps, there can be at max 4 swaps, not more than that. If there are more cycles, right? If there are more cycles, lesser are the number of swaps. Correct? That's it. Can you try implementing this before the next class? Tell me that.
Yes. Uh, yeah, Raman, but I mean, more cycles means less swaps, you're saying?
Yeah.
Okay.
If I just say that, let's suppose you are having a single cycle of 6 elements, let's say 1 to be shifted. Let's suppose 2 is getting shifted to 3. 3 is getting shifted to 4, 4 is getting shifted to 5, 5 is getting shifted to 6, 6 is getting shifted to 1, 1 going back, right? So I think 5 swaps would be required here. 2 would be at the end after 6 is getting cyclic shift to 1, 1 would be automatically shifted to the required position of 2. So there would be in total 5 swaps I'm going to require here. What if I try breaking that? Suppose the array is arranged in such a manner that your 2, 3 and 1. These are forming a simple cycle, as well as at the end 5, 4 and 6. This is forming another cycle. So I think in the bigger cycle we required 5 swaps. In the smaller 2 cycles, here 2 swaps, here 2 swaps. I am able to reduce the number of swaps by 1. Am I correct? Am I correct? Yeah.
Yes.
Smaller is the size
Yes,
of
yes.
the cycle. Smaller is the size of the cycle, lesser would be the swaps. correct? Further break it, further try breaking it. Let's suppose I am having something like this. 2 is connected to 3, so a single swap, you have to bring 2 and 3 into their respective interchange position. 2 would be going to 3, so automatically 3 would be coming into the position of 2. Again, I am saying that bring 4 and 5, and at the end just try swapping 1 and 6. This is the nature of our cycles, let's say. So I feel one swap to this, one swap to this, and one swap to this. More number of cycles, lesser are the number of swaps. You got it?
Got it.
Here it was 5, here it is 4, here it is 3. That's it. Try implementing that. I would be coding that for you in the next class, and we'll discuss simultaneously the time complexity. Okay. Fine. Please implement that first, and next day we are going to discuss further, and we'll take more problems on array. Fine. I think
Okay.
Amir is going to show to all of you the Discord part. Please stay back into the class. That's what is my request. How was the class? I think majority of you are coming for the first time. How was the class? Sorry for the yesterday's part because I was not well, so I didn't take the class. Okay.
It's good only, Raman, but I feel it's little fast.
Okay, okay. Rest people.
Good.
Fine.
Really.
Okay, so I'm gonna make Amir the new host, and you can stay back for a while to watch how to set up the Discord part. Then accordingly, he will stop the recording. Okay. Okay, fine. I am stopping the recording here. I think this
Possible
record you can set up here.
example to solve.
You stop. I think in Thursday onwards we are gonna have another class. Please solve this first, then we can take that from there. You are gonna get a sheet on arrays from Amir. Okay, he's gonna give that to you.
Okay, sir.